Okay, we're talking about direct variation. This is section 2.3. I know it seems strange for us to go backwards, but we skipped section 2.3 way back in chapter 5, or chapter 2, because we knew that it would go well with chapter 9. And I also understand we just got finished with chapter 7. We will be coming back to chapter 8 after we get through chapter 9. But 2.3 goes well with chapter 9. Direct variation. One example that we have here is y equals kx. kx. Now, that reminds me a lot of a line with a slope and a y-intercept of 0. One of the things that k cannot be is 0 itself, which would create a horizontal line situation. These are situations in which the line crosses through the origin. So that's an important thing when it comes to graphing these things. And we say things like y varies directly with x. Y varies directly with x. Let me zoom out a little bit. We have other examples, right? Y varies directly with x squared. Y varies directly with x cubed. Now these are other examples which we will not be dealing with immediately, but we will eventually be dealing with them in the not too distant future. So don't forget about them. But when we speak of direct variation, simple direct variation is just y equals kx. Now k right here actually has a name. They call it the constant of variation. I know several of you have already noticed that I misspelled the word constant, only to try to help you remember that k is the constant of variation. If you take a look at this sentence that I wrote, y varies directly with x, you will notice something that's obviously missing. I never mentioned the letter k. Constant of variation k is a number. And you're never going to see it mentioned in the variation language. When they say variation language, this is the type of stuff they're looking for. Y varies directly with x. So k is like that great aunt of yours that nobody likes to talk about because she's really weird and she makes people feel uncomfortable. You know, we all have a relative like that or so, but Aunt K never gets mentioned. But you must always know that she is there. Always. Another way to look at this, just to help you kind of get an understanding, as the x values get bigger, the absolute value of the y values gets bigger. So keep that in mind. As you go to the right, the absolute value goes up. Alright, just keep that in mind. Most of the time we are dealing with positive k values. Occasionally we see negative ones, but most of what we're dealing with is positive k values. In example 1, it says determine if y varies directly with x. Now, if y varies directly with x, and you solve that equation for k, what do you get? You get y divided by x. That means no matter what situation I'm in, every time I take the y value and divide by the x value, I get the same number. That's why they call it a constant. If you think it is direct variation, you need to do two things. You need to find the constant of variation, which will not be very hard to do, and you also need to write the equation. So here we go. Here's a set of numbers, a chart of xy values, and we need to determine y over x. So 8 over 2, 12 over 3, 20 over 5. What do you know? Every single time we got the value 4. That must mean we are dealing with direct variation. It also means that k is equal to 4. And the last thing you were asked to do was write the equation if you thought it was direct variation. That shouldn't be too hard. Y equals 4x. So yes, it is direct variation. The constant of variation is 4. And y equals 4x is the equation. Alright, try it again with a different set of numbers. Okay, we've got y over x is what we're going to try to figure out here. 4 over 1, not too hard. 7 over 2, uh-oh. That's not equal to 4. Neither is 16 over 5. Right? That's 3.2 or 3 1/5. So obviously this is not direct variation. In that case, I do not need to come up with a k value or an equation because it's not direct variation. And we haven't talked about any other types of variation to worry about. Okay, so in example 2, it says, is it direct variation? This time they're giving me an equation and I have to come up with an answer. So I start up with this equation, and the real big question that I have is, what is y divided by x? So somehow I need to manipulate this equation. So we'll start off with 3y equals 2x. I'm going to manipulate this equation. I want y over x, so I'm going to divide both sides by x. That gives me 3y over x equals 2. Well, that's still not 1y over x, so I need to do a little bit more and multiply by 1/3 on both sides. And I get y over x equals 2 over 3. Now, is this a fixed number? You ask me, well, how do I know? Well, it doesn't have a variable over here. No variable on this side. So that must mean it's a fixed number. 2/3 is not going to change. So y over x equals k. Yes, this is direct variation. And k is equal to 2/3, and the equation is y equals 2/3 x. Okay? All of that is true. Now, when you get to this next one, we want y divided by x. So that's y over x on the left side. 2x over x plus 3 over x is y over x equals 2 plus 3 over x. So the big question, is this a fixed number? And the answer is a big no, because every time x is a different value, this whole side of the equation changes. So, definitely a big no, right? Not direct variation. All right, example 3 was a story problem situation. It says a faucet wastes 1 cup of water for every 3 minutes that it's dripping. And then they give you this. Water wasted varies directly with time. Okay, right there they told me water wasted, W equals KT. That's what they just told me. Like I said before, K is never mentioned, but you better not forget that she's there. W equals K times T. Since they told me it was directly related, I knew it was K times the independent variable time. Find K. Well, all right, so 1 cup of water is wasted in 3 minutes. That must mean that the constant of variation is 1/3. So my equation is W equals 1/3 T. In this situation, 1/3 represents the number of cups of water that are wasted in 1 minute. How long till 4.5 cups are wasted? All right, so 4.5 is the amount of water that we've lost, and we're trying to find the time. Shouldn't be terribly difficult to see that I need to multiply both sides by 3 in order to get rid of the 1/3. And so we have 3 times that, or 13.5 minutes. another example, which is kind of similar. It's just not set in a story problem type fashion. It says, suppose y varies directly with x. So I automatically know this equation, y equals kx. X is 27 when y is negative 51. X is 27 when y is negative 51. Okay, so we need to divide by 27 on both sides in order to find out that k is equal to a negative number, right? 3 goes into the top and the bottom. 17 over 9. Right? All I did was take a 3 out of the top and a 3 out of the bottom. So my equation, y equals negative 17 over 9x. And it says find x when y is negative 17. So let's suppose I plug in my y value of negative 17, and I'm trying to find the x value that goes with it. What am I going to do? I'm going to multiply by the reciprocal. 9 over negative 17. 9 over negative 17. Right? Of course, all of this stuff's canceling out, leaving me x on that side. Nicely, this side's canceling out, leaving me with 9. And that's how we finish that problem off. Those are the notes about direct variation on section